Mission Control, this is Operator Derm speaking. We are initiating Operation Clear Pores, a long-range mission designed to prevent blackheads by stabilizing the skin's operating environment. This is not a product sermon, not a do these steps routine lecture, and not another dramatic storyline where blackheads are villains to be attacked. In this mission briefing, blackheads are treated as system anomalies, observable outputs that occur when certain parameters drift outside safe operating limits. Our job is not to fight anomalies with brute force. Our job is to keep the spacecraft stable so anomalies don't emerge. Think of your face as a high-precision spacecraft with thousands of pores, each one designed to release oil and shed microscopic material in a controlled manner. A blackhead is what happens when a port's release function slows. The port accumulates material, and the topmost layer changes appearance at the surface. If you've been stuck in cycles clear today, clogged next week, it means the system is oscillating. We're going to dampen the oscillation. In mission control terms, we'll define sensors, identify failure modes, set safe ranges, and implement corrective maneuvers that are gentle, repeatable, and resilient under stress, travel, sweat, and filming schedules. First, we establish the core doctrine. Systems fail when operators overreact to noisy data. Your mirror is noisy data. Bright lighting, magnification, and daily hyperinspection exaggerate perceived defects and trigger overcorrection. Overcorrection destabilizes the system, which increases anomalies, which increases inspection, which increases overcorrection. That is a classic positive feedback loop. Operation Clear Pores begins by breaking that loop. Our mission is not to make pores invisible under extreme lighting. Our mission is stable skin behavior under normal life conditions, with reduced anomaly frequency and reduced severity. We will judge success by system stability, comfort, even texture, fewer raised plugs, less repeated congestion, and reduced compulsion to intervene. Now we define our sensors. Mission Control uses sensors because guessing kills missions. You will use 3 sensors that do not require magnifying mirrors. Sensor 1 is comfort. Does your skin feel calm, non-stinging, non-tight, and non-flaky? Sensor 2 is handling frequency. How often do your hands touch your face unconsciously? Sensor 3 is film persistence. Do you end the day with a sense that layers remain on the skin even after washing, especially around the nose, chin, hairline, and jaw? These sensors predict blackhead risk better than pore-by-pore counting. Comfort tells you whether your barrier is stable. Handling frequency tells you how much mechanical stress you are applying. Film persistence tells you whether your pore openings are being burdened by residue. When these sensors drift into risky ranges, anomalies increase. Now, we identify common failure modes. Failure mode A is aggressive decontamination. Operators respond to shine or dots by over-cleansing, scrubbing, stripping, or using harsh, deep clean tactics. The immediate effect is a temporary reduction in surface oil and a sensation of cleanliness. The delayed effect is barrier stress and reactive behavior. Increased sensitivity, increased microinflammation, and often increased oil output or uneven shedding. That creates conditions for more plugs. Failure mode B is incomplete film removal. Operators apply protective and cosmetic films during the day: sunscreen, makeup, styling drift, sweat film, and remove them incompletely at night because they are tired, rushed, or using methods that smear rather than lift. Residual film changes the pore exit environment overnight. Ports become more likely to clog. Failure mode C is repeated microfriction. Operators create chronic contact stress through masks, straps, collars, phone pressure, chin-on-hand habits, wiping sweat repeatedly, or sleeping friction. Microfriction inflames port boundaries and changes shedding dynamics. Failure mode D is panic tuning. Operators change multiple variables at once: new cleanser, new serum, new mask, new exfoliant, then blame the system for unpredictable outputs. Multiple changes create noise. Noise triggers panic. Panic triggers more changes. The system never stabilizes long enough to show improvement. Failure mode E is mirror-induced manual override. Operators repeatedly extract or squeeze because they believe they are restoring function. In reality, repeated manual overrides can injure port structures and increase future anomaly risk. With failure modes defined, we set safe operating ranges. Range 1. Barrier comfort must remain in the green zone. Green zone means no persistent sting, no cracking, no chronic tightness, no raw redness around folds, and no daily flaking. A mild, short-lived adjustment sensation can occur with changes, but chronic discomfort is a red alert in mission control. When comfort is red, the system is unstable. Blackhead anomalies and texture anomalies become more frequent. Range 2. Mechanical input must be reduced. Mechanical input includes rubbing, wiping, scrubbing, squeezing, and repetitive touching. In a spacecraft, you don't kick the hull because a sensor blipped. You stabilize and observe. In skin, repeated handling is often the invisible contributor that keeps pores reactive. Range 3. Nightly decontamination must be reliable but non-destructive. This is where most missions succeed or fail. Reliable does not mean harsh. Reliable means the day's film is lifted off the surface so ports can release normally overnight. Non-destructive means you do not scratch the barrier while removing film. The correct principle is dissolve and lift, not scrub and abrade. Range 4. Variable changes must be controlled. You will not change 5 things at once. You will change one variable at a time and hold for a meaningful window so mission control can interpret outcomes. Now we implement corrective maneuvers. Corrective maneuver 1 is stabilization mode. Stabilization mode is activated when your comfort sensor is yellow or red tightness, stinging, flaking, or visible irritation. The goal is to stop the oscillation. Stabilization mode does not chase dots. Stabilization mode reduces stress signals so the port environment can normalize. In stabilization mode, you avoid harsh cleansing and you stop aggressive interventions. You keep removal gentle, you keep handling minimal, and you prioritize comfort. Comfort is not vanity. Comfort is the condition under which pores behave predictably. Corrective maneuver 2 is decontamination optimization. If film persistence is high, your removal method is failing, not your skin. Mission control doesn't blame the spacecraft for a dirty viewport. It upgrades the cleaning protocol. Decontamination optimization means matching the removal method to the film you wore. If you wore film-forming layers, heavy sunscreen, long-wear makeup, your method must dissolve and lift, rather than rub and smear. If you are rubbing hard to feel clean, you are damaging the hull. The best removal protocol is one that feels gentle while still leaving the skin comfortable and clean, not stripped. The key mission principle here is thoroughness comes from method, not force. Corrective maneuver 3 is contact control. If anomalies cluster in contact zones, treat the contact zone as the source of disturbance. You cannot out-serum a strap that rubs for 8 hours. Contact control means reducing friction time where possible, minimizing rubbing behavior, and avoiding sticky, heavy layers trapped under contact areas. It also means cleaning contact surfaces, phone screens, helmet padding, mask rotation because repeated contact with dirty surfaces increases mechanical and particulate load at the same spot. Contact control is not glamorous, but it produces measurable stability. Corrective maneuver 4 is operator training. Operator training means breaking the mirror loop. Daily magnified inspection is not monitoring, it's interference. Mission control monitors at scheduled intervals and uses consistent conditions. You do the same. Evaluate in consistent lighting, at consistent intervals, without magnification. When operators stop compulsive inspection, manual overrides decrease. When manual overrides decrease, inflammation decreases. When inflammation decreases, ports release more normally. Corrective maneuver 5 is fallback protocol engineering. A mission fails not on perfect days, but on bad days, stress, fatigue, travel, late nights. So you must design a fallback protocol you can execute even when exhausted. The fallback protocol is minimal but crucial. Remove the day's film gently, avoid trauma, and keep hands off the face. This is the difference between a minor blip and a full anomaly cascade. Now, we run the mission through simulations because mission control never launches without simulating worst-case conditions. Simulation 1, Heat and Sweat Event. In a heat event, sweat increases, wiping behavior increases, and film can become sticky. Risk: increased friction and residue at port openings. Mission response: reduce wiping friction, use gentle handling, and execute reliable end-of-day decontamination. Do not respond with aggressive stripping midday. That increases irritation signals and can destabilize the system. Simulation 2, Long Contact Event. Masks, helmets, straps, collars. Risk: microfriction and occlusion. Mission response: reduce friction where possible, avoid heavy sticky layers trapped under contact zones, cleanse gently after prolonged contact, and keep the barrier calm. Simulation 3, Filming under harsh lights. Risk: operator panic and last-minute manual overrides. Mission response: prioritize calmness and even surface behavior rather than aggressive, instant clearing. Under bright lights, irritation and flaking are amplified. Calm skin photographs better than traumatized skin. The mission teaches a hard truth. The fastest on-camera improvement often comes from doing less damage, not from doing more extraction. Simulation 4, Travel and Climate Shift. Risk: unstable water, humidity swings, sleep disruption,